12, so we're on to our second video. Fundamental theory of calculus. Sounds like it's really important. I suppose it is. Right, what we're looking at now is we are trying to evaluate that definite integral that we did before. We're going to do that without sketching the graph, and perhaps for shapes that aren't nice and familiar, like triangles, rectangles, semicircles, quadrants, and so on. Okay, we're not actually going to prove this right now. You can check it out in the textbook if you want to see the proof, but the fundamental theorem of calculus tells us that the definite integral between these bounds from A to B is equal to the value of the primitive at one bound minus the value of the primitive at the other, right, from the far right to the far left. Okay. We're going to start calling the primitive the integral. Just be familiar with that language, and I'm going to show you what I mean by this and how it works. So here we have a worked exercise. I think I'm just going to do this one, right? To keep working on time. Let's have a look at this B. So fundamental theorem tells us that, right, I can find the area under this curve from 2 to 4 in this way, right? The integral from 2 to 4 of 2x minus 3 dx equals, now we use these square brackets, right? Square brackets like this. Now we've got to find the derivative of 2x minus 3. Well, antiderivative if you like. If I differentiate x squared, I get 2x, don't I? And the same goes, negative 3x is going to give me negative 3 if I differentiate that. If I differentiate that expression there, then I get this one here. So this is a primitive of this. Now, we put these bounds in here like this, 2 to 4. We've got to be careful here with our brackets and whatever else that we don't get things out of place, but the way this is solved is, I substitute in, I start with 4. So that equals 4 squared minus 3 by 4. I'm going to put brackets around here. Minus, because we've got to subtract all of these other things. 2 squared minus 2 by 3. Of course, it's the two negatives that trip you up. If you're not being careful, not because it's hard, it's easy to get it wrong. So I've got 16 minus 12 is 4. Minus 4 minus 6 is negative 2. So that is... So that was 4 minus negative 2. So that's going to be 6. Okay, that's the value there. Just like that. So a little bit easier than sketching and calculating areas and so on. Righto. Now it does ask us to draw a diagram and sketch this, so what would that look like? Well, here's x and y, 2x minus 3, that's what we're looking at, so that looks like this. And so it's negative 3 here, and we want it between, there's going to be 1.5 there, can we say that, 1.5 here? And we want it between 2 and 4. That's 2 there, and 4 there, okay. That's the region that we're interested in. Now, the trapezium, you can go back and work that out. You should get an answer of 6. I'm pretty confident you're going to get an answer of 6, unless I've made a mistake. I hope that's not the case. Anyhow, right, normally you won't have to sketch it, but we're going to for this example, because it asks us to. Let's look at the next example. Right, this time let's just do the first one. Right, we did the second one last time. Evaluate the following definite integrals. So the integral from 0 to 1. We've got to get familiar with the language, the terminology, and these little scripts and whatever else, of x squared dx equals, square brackets now, big square brackets. Now, 1/3 x cubed, right? We don't have to worry about the constant because we subtract one from the other. We're going to take the same thing away each time. So we get this from 0 to 1. If I don't have those bounds, well, we're going to find out about that later. But for the definite integral, right, I substitute 1 in, and I substitute 0 in, and I take those away. Of course, once I substitute 0 in, that's minus nothing. So all I get is 1/3. That is the value of that definite integral. I reckon we've got time here. We can still squeeze in b. That's a and b. Now we've got the integral from negative 2 to 2 of x cubed plus 8 dx. Okay, so we need to integrate this. X cubed is going to be 1/4 of x to the 4, and that's going to be 8 x. Remember, we don't need to worry about our constant here. Our constant here, because it's a definite integral, because I've got these bounds in here from -2 to 2. But I do have to substitute those things in. So, we kick off with 2. 2 to the power of 4 is 16. 1/4 of 16 is 4. 4 plus 16 is 20. Oh, come on. 20 minus. Again, I have -2 to the power of 4 is going to be 16/4. That is 4. 4 minus 16 this time. 4 minus 16, -12. So it's 20 minus -12 equals 32. Righto? And that's it. That's how you evaluate a definite integral. I've done it for a few different things. That's all you need to do for now. Check that out. We will work through a bunch of these in class, and I'll be there to answer any questions. Thanks, guys.